Good day, this is John from DAM Machine Shop. Here I am, I'm actually in the shop on a Sunday, and I'm working on needle drop with the new dual needle and seat float bowls, and I wanted to show in a single needle and seat float bowl just the progression with the needle drop. I know we've sent some pictures out in some different videos. This is such an important area that I spent a lot of time looking at, because in order to get the high flow you have to have needle drop, and some of the things people just don't think about that I'm forced to think about for fuel flow are needle drop, how much of the needle in the exit window, which is what we're looking at now, the exit side window, is exposed in order to deliver fuel in the float bowl. That's just to get it in there, and then how it goes down inside of the float itself, distributed in the float bowl itself. A very common float to be used is this center hinge. They call it, the side hung float. This is a center hung float. And you can see, and I tried to hold it up so you can see where it would be in the window in the side. That's why I wanted to do this little thing. Excuse my fingers. There's a side window, and the seam, which is what we're using for right now, and where it would be in the side window. That's a pretty good spot where the floats will think, depending on the amount of pressure. And I'm holding the needle and seat at that level with my left thumb, and so you can see it has pretty good needle drop. As the camera goes in and out of focus, we'll give it a moment to refocus. And how important this is. Well, the fulcrum distance on a center hung float is fairly short. I'm going to pull the needle out now. Let me bring this back a little bit. So the distance between the fulcrum and the thing, that's a fairly short distance. Moving to the side hung float, I bent this up a bunch, working on it to make it work within efforts to try it. And I'm going to use, in this case, a long drill so you can see the fulcrum points here. And how much different they are. So you're looking at how much distance there is between the fulcrum and the edge of the float, and how much it's going to drop. Let me just swap this tool. This drill's a little too long to demonstrate what I'm trying to show. So we'll use this Allen wrench here. It's how much distance from the fulcrum there is out to the edge. If I rotate the fulcrum, you can see that the center hung float, this one here, will drop more because of the length between the float and the hinge pin. Alright. And actually the side hung float, this float here, because of its height and length, doesn't really give you as much angle change between the hinge pin and where it would support the needle and seat. Now let me just, because I bent this one all up so it'll actually fit in this. Normally it wouldn't fit, but I'm going to go ahead and stick it in here. And one of the reasons why I did this is because in the development of the new needle and seats, one of my first thoughts was to use the side hung float excuse me excuse me, two of the side hung floats in our new dual needle and seat float bowls. Let me just get this in here. Give me a moment. My fingers are big, and this is not an easy assembly here with this particular float. There we go. Am I getting it? Not yet. Hang on. There we go. I think I've got it. Yeah, I've got it. All right, so the height of the new float ball is going to be the same, but I'm trying to show here now. Let me just reduce this a little bit. Get that to come in focus. Is the amount of distance that this float is going to move, even if it goes from top to bottom, is a fairly small distance. We put the needle and seat in there. So I'm going to go all the way up to the top, and I'm going to just hold it with the float all the way to the top. I'm going to pinch now the needle and seat. And then when we go in there, I'm going to make that bigger now. Hang on, move this over here. So we're going to close the needle and seat, which you can't really see through the float right now. So it's all the way at the top of the inside of the float ball. And even with it going all the way to the bottom, you can see that the needle and seat barely opens as it did before. Before, the needle would go all the way down to the bottom of the window for the, this is actually exit side. It's the inside the float ball side. So even though this is getting full travel all the way to the top and the bottom, we're getting very little needle drop. So in this selection of floats, let me just get the next one we evolved through. I found another float. Let me take this one out, and I'm going to put this one in. There we go. And I'm going to do the same thing. I'm going to bring the float all the way up to the top and just reduce just a tiny bit. And then down just a little bit. I'm going to hold up my finger. Then we're going to look inside there. We're going to go up and then drop. And so you can see it. Focus there a little bit. And you can see virtually we get the entire distance of the needle drop now. I'm going to rotate it a little bit so you can see it go all the way up right there. Compared to the other one, we get maybe 3/4, 7/8 of the needle falling out of the seat. Alright, so we just got another float in. And I'm going to install this one now real quick. And this is a brass float. We're going to do a full test with buoyancy, needle drop, and everything. When we get the dual needle and seat float balls completely done, we're actually going to install one of each of these floats in that carb so you can see it in the float ball. So this one go all the way up and drop down to the bottom. And you can see we get pretty good needle drop from this float. So we do our full test. I'm going to take and put one of the brass floats in. Let me just take this out now and give you another little demonstration of what I look at. Is I'll take these floats and put them on the same axis. Make this a little smaller here. Because there's more than just this angle change. I want you to see this as well. So we've got the same thing. We're going to go here, and we're just going to go down and travel. See if I can show this. Move the camera here a little bit. So we take the same axis pin, and we're going to go up and see the bottom, these two here are pretty close to the same. But when we go down with the axis and the float rotates up, you'll see that the composite float moves more quickly, so that means it's going to have less. If we brought them to the same height, it would actually have less needle drop than the brass float. Alright, and I'm going to show the brass float compared to the Holley side hung float. You can see the Holley float has much less distance. If I come over here and go up to the same distance, this is how much more the brass float gives for needle drop. Just within that same distance. Let me just change out and put the other float in there now. This may seem like a lot, but when we're selling the parts and people want fuel delivery, here's the go up and down, so the bottom part is the same on these two floats here, but then you gain this much more distance for needle drop from the top. And when we go back to the same, we go from the, let me compare once again. Now this is the center hung float compared to our new composite float. So it gives you an idea on that one. I can't hang them both on the same one. I have to use a long drill here. Alright. So you see that the series of floats that I'm using have a very similar axis rotation distance as the center hung float, which is important in order to get the needle drop, as I showed you. Let's just see if I can use a small thing here and show you with the brass float. It all seems like a lot, but this is what we go through in order to make sure the products will work. And the difference between the composite, a lot of times the brass float will give a little bit more buoyancy, but it has more inertia weight. So you can see here with the brass float and the center hung float, there's still a pretty different things. When you get past this particular distance, the brass float, you can see the gain on the center hung float is a little bit greater past that point, but that's actually past what would be rotating in the float ball. I've already checked it there. But the brass float being a little shorter than the composite float, let me just put these two together now. Hang on a second. Gotta hold the camera as I'm. I just dropped the camera. Hang on one moment. Let me put the camera back in a little hole I made here. Oops. There we go. I'm going to use two hands. Alright. Now we're going to compare the brass float with the composite float on the same axis pin. So through the rotation, if I bring the brass float up to the same thing, I get more distance out of the brass float. And when you see it in the float balls I showed you before, you can't see a lot because inside the float ball it can only go so far. But the brass float offers a tiny bit more needle drop than the composite float. So the times that we're going to use the composite float, as silly as it sounds, the number one thing is you can't overnight via air freight the brass floats, because the pressure differential in the airplane will actually collapse the brass float. We had that happen when we were overnighting carbs in the NASCAR, when we were doing NASCAR carburetors, and they need them overnight. We would send them there, and the floats would be crushed from the pressure differential in the airplane, so that we could only overnight carburetors that had composite floats. And then there was a slight difference in the inertia, but a lot of times the buoyancy, when you're looking at pressure, there's more buoyancy in the brass float than there is in the composite float. So we have to go back and forth between needle drop, buoyancy versus pressure, and how we're going to deliver the carburetor. So there's a lot of considerations in this stuff, and I wanted to do a video because I spent a lot of time on this recently with the new dual needle and seat float bowls, because we need, part of the purpose of putting the dual needle and seat is a fuel volume. And that has to be considered. You don't, if we went to the Holley side hung float and make that a choice, then we get very, it all looks good as dual needle and seats, but we get very little needle drop, so therefore our fuel volume goes down. So in order to make the whole thing work, we had to find more selections, and we've come up with these truly two awesome floats that do everything proper. And I'm going to put them both in the same float bowl at some point and show you which one supports the pressure and fuel delivery while it's, actually having fuel come through it. What I want to do today is just on the different choices that we're making in our new dual needle and seat float bowl. So thanks for listening. Talk soon. Have a great day. Bye.